This tutorial will illustrate how to add and utilize control loops in your total view configuration. Control loops are capable of regulating your process to prevent or correct any deviation from nominal. Control loops are an additional option that may be purchased from LaserLink. In order to set up a control loop, a control measurement must first be made. A control measurement will be used as a reference, and the control loop will adjust your process based on this reference. Control measurements typically have a large amount of averaging in order to ensure that control moves are only made as a result of gradual changes in your process. If you need a refresher on how to make a measurement, please see the tutorial titled Adding a Measurement. Once this desired measurement has been made, a control loop may be set up. To add a control loop, open Full Configuration by pressing Total View on the main application window and select Full Configuration. Double-click on Control, then double-click Add Control to add a control loop. If a digital signal is being used, determine if your hardware can detect pulse width or pulse count. If your system detects the pulse width of a digital signal, select the radio button next to Digital Relay Output. If your system detects the pulse count of a digital signal, select the radio button next to Digital Pulse Count. If you are using a LaserLink motorized potentiometer, select the radio button next to LaserLink Mop. The proper channel must be selected in the drop-down bar under Channel. The channel numbers must be consistent with the wiring done inside the input-output box. Once you have selected a radio button and channel, hit Next. The screen will look different depending on the interface option chosen before. If the Digital Relay Output radio button was selected, you will now see options for direction and pulse width resolution. You will want to select the radio button that is consistent with the wiring done inside the input-output device. Next, you will select Pulse Width Resolution. Select a resolution appropriate for the controlled machine. If the Digital Pulse Count radio button was selected, you will see options for direction and pulse width. Select the appropriate button. Next, you will select the pulse width. You will need to determine the minimum time required for your system to detect a pulse and enter a length of time longer than this in the edit box shown here. If LaserLink Mop was selected, you will now see options for direction and pulse width resolution. If the mop will be controlling a pooler, extruder, or air pressure system, select the appropriate radio button here. If the mop will be used to increase or decrease the control measurement, select the appropriate radio button to indicate what a clockwise turn will do. Once a direction has been selected, the pulse width resolution must be selected. Hit Next. Select the control measurement that was previously set up for this control loop in the drop-down tab. Next, you will choose the number of scans to average your control measurement. It is important to average the control measurement over several seconds or more to ensure any outliers do not drastically affect the system. The higher the scan speed of your scanner, the more scan averaging needs to be done. Once you have entered the number of scans to average your control measurement, hit Next. Here we have options to set the gain and to determine the minimum and maximum compensation. The gain will be multiplied by the amount of deviation from the deadband limits of the control measurement to determine the amount of compensation required to control your product. This will equal the output pulse width or count per unit deviation, depending on the previous settings selected. If a minimum or maximum compensation is desired, it may be added in the corresponding edit boxes shown below. Hit Next. Next, you will input a control delay. This delay is the time or distance in between each control move. In order to control your progress gradually, a large enough delay must be chosen so that a control move has time to take effect before the control loop makes another control move. You may choose between a delay in seconds or a delay in feet. If you choose a delay based on footage, the delay distance should be greater than or equal to the distance between the controlled device and the scanner. Select the appropriate radio button and choose the amount of delay. Hit Next. Here you will see options to enable dual loop control, adaptive control, profit maximizer, and shrinkage compensation. Check the radio button next to dual loop control if you are using two control loops to monitor the same process. Check the radio button next to adaptive control if you want the control loop to automatically adjust the gain or deadband limits based on user specifications. Select the radio button next to profit maximizer if you want to control your process near the deadband limits. Select the radio button next to shrinkage compensation if your product is being controlled while it's still hot. This setting will adjust for shrinkage due to cooling. Hit Next. The status labels refer to the label the operator will see when there is a control output change. For example, if a decrease in the control measurement is detected, an operator may wish to see the word increase, which may correspond to the control loop attempting to increase the diameter of your process. Conversely, the operator may wish to see the word decrease, which may signify to the operator that their motor speed is being decreased to once again increase the outer diameter of your product. Once you have determined the desired labels, select the appropriate radio button for counter X and counter Y. Hit Next. Name the control loop and hit Finish. Next, I will go over how to make deadband limits for your control loop. Deadband limits are the parameters in the system set to the control measurement that determine if a control move should be made. Deadband limits should be tighter than specification limits and wider than the natural drift of your process. To create deadband limits, double-click on Recipes. Deadband limits may be added to any existing recipe. To add deadband limits to a recipe, double-click on the recipe you wish to edit. Click the button Add Specification. In the box labeled Available Measurements, select your control measurement and click Add. Enter the appropriate values for your deadband limits in the edit boxes shown on the left. Click OK. This recipe will now allow the control loop to reference the control measurement to the deadband limits and make control moves if necessary. I will now show a control loop in action. This first setup is using a precision timer relay board, which outputs a digital signal. In this setup, you will see how control moves affect the diameter of a wire currently being scanned. I have set up two jog buttons which can be used to manually make a control move up or down. I also have a button that will switch from manual to auto control. Beneath this is a control loop display window, which tells you whether you're in manual or automatic mode. On the bottom left is a position window showing the position of the wire currently in the scanner. Finally, to the right is a chart of the wire diameter as it is being scanned. As you can see, the wire is currently out of spec. A control move is required to get the wire back in spec. Hitting the jog up button will cause the wire diameter to increase. Now the wire is in spec. Hitting the jog down button will decrease the diameter of the wire. The wire is once again out of spec. I will now hit the button titled Control Loop Manual to switch the control loop to automatic mode. Once I hit this button, the control loop will immediately make a control move to try to increase the diameter of the wire, since the wire is currently under the minimum diameter. Next, I will show how the LaserLink mop is used. The mop must be connected to a digital input-output box you are currently using. The mop has a dial that can be set to any initial value. When a control move is made, the dial will turn to reflect control change. The mop dial has a set range, so setting its initial value is important. If there is an upper limit or a lower limit to your control moves, ensure that the dial can rotate through that amount. Make sure the control loop is set to use our LaserLink mop and the dial has been turned to your preferred starting location. The mop is now ready for use. Switch the mop to manual mode if it is not in manual mode already. The control status window is now reading manual. Just like before, the jog buttons can be pressed to manually make a control move. You will notice, however, that by making a control move, the dial on the mop will turn. Switching the mop to automatic will automatically make control moves if they are necessary. Every control move will turn the dial on the mop to a certain distance. This distance is determined by the gain entered in the control loop configuration and the amount of deviation seen in the product.